The Psyche mission is a Discovery-class mission at NASA JPL. The mission is going to go to the Psyche asteroid, which is out in the asteroid belt between Mars and Jupiter. Most things in the asteroid belt are either rock or ice. And what makes Psyche really unique is this nickel-iron composition. Onboard Psyche is also a technology demonstration called DSOC. It's the Deep Space Optical Communications payload that's built by JPL. This is going to be transferring data via photons instead of radio waves, and this will really push a lot of future missions forward because we can get so much more data down at a time.
Our team here at Aerospace, I think we're accustomed to spinning up quickly, to supporting a project to where we can make an impact fast.
If we're given a problem set and someone says, hey, we need to verify, that this is happening, this is happening, this is happening, we know exactly what we need to do to verify something. We know the types of tests we need to develop. We know the types of software that we might need to write, the types of tools that we might need to create. And so it's a very natural transition for us to do that kind of work. And that's exactly what JPL and Psyche wanted from us at that point.
We exhaustively tested the ability to perform the nominal operations, to be able to get from Earth to Psyche, but also the ability for the spacecraft to recover itself and be stable in the event of some kind of fault that occurred on board.
I support the Psyche Testbed Tools team. We're a small team devoted to essentially making testing easier for other users. The tools that we develop are used around the clock across 3 different hardware test beds. The tests that we do are where we prove out the flight software before it goes on the actual flight system. It's also where the team learns to operate the spacecraft, where we find those bugs, and how a lot of the team prepares for various phases of actual flight operations.
One of the tools I developed was the parameter cert verification tool. It verifies about 9,000 parameters in a few seconds and essentially helps the parameter lead give a thumbs up or a thumbs down on the set of parameters for the mission.
We actually have planned dictionary releases, flight software updates for the duration of the mission that the JPL Psyche team can update the spacecraft in flight just through radio signals. And so some changes that we can't make until JPL's measured certain parameters in space and certain environmental effects. And once we get that data, the engineer is able to give us changes that they need to make to the dictionary accordingly. Our trajectory analysis is going to keep getting better and change as the mission progresses. So our burn profiles might change slightly. So all of that needs to be controlled on the ground. And so that's what the operators are creating sequences for and uploading for the spacecraft to run.
I've been designing test cases that put the spacecraft into various conditions, and we verify that when a fault is injected, that the spacecraft can autonomously safe itself into a position where ground operators can then intervene.
It was almost a little bit of puzzle work to make sure all the pieces fit together and that the tests were accomplishing what they needed to. I'm psyched for Psyche.